Hello, ladies and gentlemen. Thank you for joining me. Thank you, one and all. We're looking at question number 8 on our 2011 Alberta Part 1 paper. F of x is a quadratic polynomial. We know f of 1 is 2, f of 2 is 4, and f of 3 is 8. Well, those are powers of 2, but of course 2 to the x is not a quadratic polynomial. We want to know what's the value of f at 4. So there's a couple ways you can do this. If you actually do first and second differences, there is a way to work out what the actual polynomial is. Okay? So you may have seen first differences. It's how you actually tell if you've got a quadratic or a linear polynomial. So we take the actual f of x's, and these have to be for consecutive ones. So 2, 4, 8. The first differences, just take differences between consecutive ones, so 2 and 4. And the second difference is if you're looking at a degree 2 polynomial, so the highest thing you see is an x squared. The second differences are constant. Now, we would need something else to tell us, just if we were looking out in the wild, that this must be quadratic. In order, you need to see some 2's to really get a sense that the second differences are constant. But they told me it's quadratic. So I know the second differences are constant. So the next second difference would be 2. And now we can sort of build up. That one's got to be 6. And so our next term, which would be f at 4, has to be 14. So that's a nice way to do it. As I said, so there's B is our answer. As I said, there actually is a way to just look at these ones here and use a little bit of combinatorics and actually work out your quadratic. Let's look at this another way. Okay, this way is going to be a little slower. It's not going to use first and second differences, but we're going to work out what f of x actually is. Here, I have no idea what f of x is. I don't care because they asked me for f at 4. But let me show you another way to do the question, just in case, in the future they give us f at 1, f at 2, and f at 5, and they ask for f at 4. This wouldn't work. The next technique will work. Okay, so it's something to keep in mind. It takes a little while longer. Okay, so let's say our polynomial looks like ax squared plus bx plus c. We know f at 1, which would then be a plus b plus c, is 2. So the sum of the coefficients is 2. All right. F at 2, 2 squared is 4. And so we get these here. Now I can take these equations. I can take the first one and subtract away the second one. Get rid of that pesky c term. So 3a plus b, 4a's minus an a and 2a's minus a b, and then the c's cancel out, must be 2. So we're starting to work out equations for a's and b's. And we've got one more. F at 3, which would be 9a plus 3b, just plugging 3 in for x, plus c is equal to 8. Okay? Well, what did I just work out? I just worked out 3a plus b is 2. Now, if I multiply that by 3, I get 9a plus 3b is 6. And we just play around with this. We could line up the third equation and the second one. I just happened to notice that this part here matches up with this part here. So I know that this is 6 plus c is 8. Well, then I guess that means c has to be 2. To plug that back up in here, c's got to be 2. A plus b has to be 0. And we just use this sort of elimination. We use a few values of our function to create sort of a linear system of equations involving a's, b's, and c's. And we just try and solve them as best we know how. So we turn it from a guess the next quadratic into a solve a linear system. So now I know a plus b is 0. I know 3a plus b is 2. So what we could multiply the top by 3. 3 times 3 and then 0. Subtract the bottom from the top. You'll get no a's and you'll get 2 b's. You'll get negative 2. So b's got to be negative 1. B and a add up to 0, so a's got to be 1. So my function looks like x squared minus x plus 2. Okay? And so we can double check. You plug in 1. 1 minus 1 plus 2 is 2. 4 minus 2 plus 2 is 4. 9 minus 3 plus 2 is 8. And so now I want f at 4. 16 minus 4 plus 2 is 14, the one that we worked out with our first differences. Okay? But this can work, as long as you know you've got a quadratic, this technique can work for any of them, or for any inputs. So, if we had known f at 1, f at 3, and f at 17, we could have solved the equation. It would have been a pain, but we could have solved the equations. Whereas the first difference, the second difference technique that I did very, very quickly at the start, really relies on the niceness of this question that we happen to be given terms in a row. Okay? If we didn't have that, we wouldn't have second differences that we could have calculated. But you can always get a nice system of equations. 3 unknowns, because you would know P, Q, and R. The unknowns are A, B, and C, and so we would solve for them. And we would get our quadratic. So that's the long way around, but that always works. So you can take that and use that for future questions. Okay, but that's question number 8. So up next, we're going to take a look at, what do we got here? Question number 9. So you feel free to join me for that shortly.